So we're asked to solve this differential equation here using an integrating factor. So the first thing is what the equation needs to look like in order to use an integrating factor. So the answer is we need to be able to write it in the form y dash plus p as a function of t, so something with t's in it, multiplied by y is equal to something else on the other side of the equation, which is exclusively in terms of t. So if we're able to do that, then the integrating factor that we want to use, which we give the symbol mu, is going to be equal to e to the integral of p with respect to t. So we need to just read this part out of the equation. Alright, so if we're going to use our integrating factor, let's start by trying to make our equation look like this one here. So what I might do is try and move so we have the y dash and any y's in our equation, which I can see here, so that they're on the same side, like in that general form. So the only y we have, I'm going to shift over. So it's going to become ty dash plus 4y is equal to the rest of this. Alright, so the next thing I'm going to do is we can see that y dash here is on its own. So we need to change it here so that we have y dash on its own, which means we need to divide the entire equation by t. So let's go through and do that. So y dash is going to become 4 over ty. One of the t's is going to cancel here, so we're left with 3t. And for this one, we're going to end up with an extra t on the bottom line, so it will be t to the power of 4. Alright, so let's just quickly do a double check against this general form. So we have y dash on its own. We have a function p of t, which is going to be this part here, the 4 on t, and it's only a function of t, which is what we were looking for. And it's then multiplied by y, so that's good. And then on the right-hand side of the equation here, we can see that it's only in terms of t. There's no other variable like a y, which is what we were, again, looking for in the general form. So that's all good. So we should be able to use an integrating factor, and we know that we set it equal to the integral of, e to the power of the integral of p of t. So in our case, this is what the p of t is. It's the 4 over t, whatever was out the front of the y. Alright, so let's go through and actually find this integrating factor. So mu of t. Alright, so I'll sub in. So it's going to be 4 over t dt, and we can perform that integral. So we know the integral of 1 on t would just be natural log of t, and we have a 4 that's going to appear out the front of that. So 4 natural log t. And we can do a little bit of algebra on this to make it a bit nicer. So one of the log rules is that you can rewrite the 4, or the number out the front, as a power inside the bracket. So we could write this as t to the power of 4 instead. And then another one of our log rules is that if we have e raised to the power of a natural log, essentially these cancel out each other and you end up whatever's inside the bracket falling out. So we can simplify this to just t to the power of 4. So that there is going to be our integrating factor. Alright, so the next step is to take this integrating factor that we've identified and multiply it by everything in the equation up here. Alright, so we'll multiply left and right hand side. So what that is going to leave us with is t to the power of 4 multiplied by y dash plus 4 on t y, and it's equal to, it's going to be t to the 4 3t plus 2 cos of t all on t to the 4. Alright, so let's actually multiply this in everywhere. So we're going to end up with t to the 4 y dash, and 4, now we're going to have these kind of cancelling out with each other, so overall this becomes t to the 3. Multiplying it in here, we're going to get t to the 5, and these are going to cancel top and bottom line, so 2 cos of t is left over. Alright, so the trick of doing all of this is what we should see is on the left hand side we've got some version of the product rule. So just as a quick reminder, if you've got like f of x is equal to u times v, where u and v are both functions of x as well, the derivative is uv dash plus vu dash. Okay, so if we look at here, what we should see is this kind of pattern emerging. So if I take, for instance, t to the power of 4, if I was to take the derivative of this, it should go 4t to the power of 3. So it looks like that. Same kind of thing, if I have y on its own and I take the derivative of it with respect to t, what it's going to turn into is y dash or dy dt, which is what I see there. So it kind of follows this pattern, right? So we have a u, if we take its derivative, it appears in the other term. And if we have a v and we take its derivative, it appears in the other term as well. So we can definitely see the product rule has emerged, and we could rewrite this now as just u times v, all right, which are these two ones that I've underlined here, the derivative of all of it, okay? So this is equivalent to uv all dashed. So let's go back and pop it in. So it's going to be t to the 4 and y as our u and v in this case. The derivative of all of it was equal to this previous line, and I'll just copy across this other section. Alright, so the reason that we've done that is because now it should be quite easy for us to integrate both sides of the equation. So we're integrating and everything's in terms of t, so it's going to be with respect to t on both sides. And what we should see here is like we've got the derivative of an integral, alright? So what happens is those two operations cancel each other out, and we just end up with t to the 4 times y, whatever was in the bracket, right? It's just like going one step up the chain here in terms of performing the integral. Alright, so now on the right hand side, taking the integral, this is just the power rule. So add 1 to the power and divide by the new power. And this one we're integrating cos, so cos goes to sine when we integrate. And what we can see is we've taken two indefinite integrals, so technically we should have that integration constant c falling out, and you could put it on both sides of the equation, but they're just constants, so they're going to end up being bunched together anyway in the end. So I'm just going to pop it on one side, so this is our little plus c. And the final thing that we want to do is we're not really interested in what t to the power of 4 times y is, right? That's not the goal here. The goal was to get y equals on its own, okay? Because that's the solution, if we scroll all the way back up, to this differential equation. We want y equals something in terms of t. So what I can do is divide everything by t to the power of 4. So that's going to disappear. If I divide this one by t to the power of 4, I'm going to be left with t squared. And I'll put the fraction together as well. So it's going to be a half t squared. Dividing this one, I'm going to get t to the 4 on the bottom line. And then my little constant here is going to get divided by t to the 4 as well. So that's pretty much all we can do in terms of this question. We weren't given any initial conditions or boundary conditions or anything else to be able to solve with. So that's the answer, the best we can do. So that's all there is in terms of this video.